Welcome to our new video. In this video, we are going to discuss about random forest algorithm. First, we will see why the random forest is better than our good old decision tree. And then I will explain how it works with visualization. Let's get started. To begin our journey, we need a data set. Here, I am taking a small data set with only 6 instances and 5 features. As you can see, the target variable y takes 2 values, 0 and 1. Hence, it's a binary classification problem. First of all, we need to understand why do we even need the random forest when we already have a decision trees. Let's draw the decision tree for the data set. Now, if you don't know what a decision tree resulting is or how it is trained, then ID. In short, a decision tree split the data set recursively using the decision nodes unless we are left with pure leaf nodes, and it finds the best split by maximizing the entropy gain. If a data sample satisfies the condition at a decision node, then it moves to the left child, else it moves to the right and finally reaches a leaf node where a class label is assigned to it. So, what's the problem with decision tree? Let's change our training data slightly. Focus on the row with ID 1. We are changing the x0 and x1 features. Now, if we train our trees on this modified data set, we will get a completely different trees. This shows as that decision trees are highly sensitive to the training data, which could result in high variance. So, our model might fail to generalize. Here comes the random forest algorithm. It is a collection of multiple random decision trees and it is much less sensitive to the training data. You can guess that we are multiple trees here, the name forest. But why it's called random? Let me show you the process of creating a random forest. The first step is to build new data set from our original data. To maintain the simplicity, we will build only 4. We are gonna randomly select rows from the original data to build our new data set, and every data set will contain the same number of rows as the original one. Here the first data set. Due to lack of space, I am writing only the row IDs. Notice that row 2 and 5 comes more than once. That's because we are performing random sampling with replacement. That means after selecting a row, we are putting it back into the data. And here are the rest of the data set. The process we just followed to create a new data set is called bootstrapping. Now we will train a data set decision trees on each the bootstrapped data set independently. But here the twist, we won't be every features after training the trees. We will randomly select a subset of features for each trees and use only them for training. For example, in the first case, we will only use the feature x0 and x1. Similarly, here we are using x2 and x3, x2 and x4 and x2 and x3. Now that we have got the data and the feature subset to build the trees. But how to make a prediction using this forest? We will pass this data point through each trees one by one and note down the predictions. Now we have to combine all the predictions. As it's a classification problem, we will take the majority voting. Clearly 1 is the winner here, hence the prediction from our random forest is 1. So in the random forest, we first perform bootstrapping, then aggregation, and in the jargon it's called bagging. Okay. So that was how we build a random forest now, and I should discuss some of the very important points related to this. The first one, why it's called random? Because we have used two random process, bootstrapping and random feature selection. If you use every feature, then most of your trees will have the same decision nodes and will act very similarly. That will increase the variance. And the next one is why bootstrapping and feature selection? The first point is bootstrapping ensures that we are not using the same data for every trees, so in a way it helps our model to be less sensitive to the original training data. And the random feature selection is help to reduce the correlation between the trees. If you use every features, then most of your trees will have the same decision nodes and they will act very similarly. That will increase the variance. And the last point is some of the trees will be trained on less important features, so they will give bad predictions. But there will also be some trees that give bad predictions in the opposite direction, so they will balance out. And the next one is what's the ideal size of the feature subset? In our case, we took two features which is close to the square root of the total number of features, that is 5. So, researchers found that values close to the log and square root of the total number of features work well. At last, how to use this for regression? While combining the predictions, just take the average and you are all set to use it for regression problem. So that was all about it, and I hope you now have a pretty good understanding of the random forest. Thanks for watching.